This video is more about function composition. All right, so last time we did talk about function composition. This time we're going to go more in depth about the composition of two functions. So let's start by taking a look at this table. And we're just going to follow along and do whatever it tells us to do. So here it wants the solution for t of 4. Well, t is time to mo. T of 4, 16. Easy enough. Read the table. If we move on to b, it says c of 4. That's cost to mo. So c of 4 is 110. Now here comes the composition part. We got to do c of t of 1. So t of 1. T of 1 is 4. Then c of 4 is 110. It's a little roundabout, I know, but I promise it makes sense. So c of t of 4. So if I said t of 4 is 16, I plug that into the c function as 16, and I get 350. So I'm taking the output from one and putting it as the input in the other, just like we did in the previous lesson. All right, so we're going to do a little bit more practice with this. We're going to use the tables below to evaluate each expression. All right, cool. F of 3. So f of 3 looks to me like it's 1. Cool. The next one is g of 3. G of 3 looks to me like it's 2. Pretty straightforward. Here comes the fun one, g of f of 3. So I'm going to do f of 3, which is 1. Then I'm going to plug that into g. And g of 1 is 4. The next one is f of g of 3. So g of 3 is 2. I'm going to plug the 2 into the f of x, and I get 2. So it's taking the output from one thing and using it as the input for something else. That's kind of the basis of function composition. Let's go on to the next page. So we're going to do f of g of x and g of f of x for those tables that were up here. So let's kind of scooch. So if I put in x is 1, right? If I put it in to g of x, so I'm putting in x as I'm putting in 1, all right, and then that goes over to the other one. So 4 goes into this one, and I get 4 out. I'm going to do it again. So I'm going to start in G and then go to F. So I'm starting in G with 2. I'm getting a 3. I'm going over here 3, and X comes out as a 1. I'm going to do it again. I'm going to start off with my G as 3. I get out a 2. I put a 2 in over here, and I get a 2 out. I'm going to do it again with 4. I put in a 4. I get out a 1. I put in a 1. I get out a 3. And that's how a table works. We're going to do it now the opposite way. You want confusing. You finally get used to one pattern, then give you another one. So I'm going to start with f of 1, and I get out a 3, and then that 3 goes into the g, and I get a 2. So I put in that. All right. I'm going to put my f as a, let's see, a 2. I get out a 2. I put the g in as a 2. I get out a 3. I put my f in as a 3. I get out a 1. I put in a 1 for my g. I get out a 4. And lastly, let's see, for my f, I put in a 4. I get out a 4. So I put a 4 in over here, and I get a 1 out. A little bit weird, isn't it? Function composition, it can be a little bit strange, but that's okay. So now we're going to do some more kind of algebraic function composition. So we're going to evaluate each expression. So let's go ahead and just work our way through this. These aren't too bad. F of 2, so f of 2, so we put a 2 in here. 2 times 2 is 4, right? So 2 squared is 4. And then we're going to put that in for g. So 2 times 4 is 8, minus 1 is 7. Easy enough. This one says g of 2. So put a 2 here. 2 times 2 is 4, minus 1 is 3. I'm going to plug that in for my x here. So 3 squared is going to be 9. Now what I'm going to do is write them as actual composite functions. So if I was going to do that, I would say that g of f of x, g of f of x is equal to 2 times, I'm replacing that x value in there with the x squared, and then I've got the minus 1. So I end up with the equation of 2x squared minus 1 as my composite function. My other one, which would be f of g of x, I'm going to do the exact opposite. My squared, but my x is going to be the 2x minus 1. If I was a good mathematician, I'm going to do this over the side. 2x minus 1. We're going to distribute that out, the square. 2x times 2x is 4x squared. And then we get a minus 2x, and another minus 2x, and a plus 1. So this equals 4x squared minus 4x minus 1, or plus 1. All right, so we're going to verify that these are the right answers by doing the same thing. We're going to plug the numbers in. So let's plug in 2. So 2 times 2, 2 squared is 4. 4 times 2 is 8, minus 1 is 7. That one checked out. The other one we're going to do 2. Okay, this was a little bit more complicated, so let's go ahead and actually write this one out. 4 times 2 squared minus 4 times 2 plus 1. So 4 times 2, 2 times 2 is 4. 4 times 2 is 8 minus 8 plus 1. Whoops, geez, Mr. Clark. What, an 8? That should be a 16. 4 times 4 is 16. You're a goofus. All right. 16 minus 8 is going to be 8. Plus 1 is going to give us 9. So yes, they both verify and give us the correct solution. Okay, next we're going to be evaluating h of g of 3. My goodness. I'm actually going to go ahead and write that down so that I remember what's going on. So that would be 2 times the 3 we're plugging in minus 1 equals 5. And that would be the g of x, right? G of x, 2x minus 1, 2x minus 1. All right, cool. So I'm not crazy. We're going to plug that into h. And h is 4x minus 3. So it'll be 4 times our answer 5 minus 3. So that's 20 minus 3, which is 17. So we're going to write that function composition so that we wouldn't have to go back and forth. And that would be 4 times the g, and the g was 2x minus 1. And then we've got the minus 3 out here. And that's how hard it is. We're just putting the one function inside the other function where the x previously was. All right, now we're going to, it looks like, evaluate g of 2. Weird. Okay, so the g function was 2x minus 1. So 2, the x is 2 minus 1. 2 times 2 is 4, minus 1 is 3. And I'm going to plug that in again to the same function, and I get 6 minus 1 is 5. It's kind of a weird way to do it, but all right. So g of x. G of x was 2x minus 1. So 2 times 2x minus 1 minus 1. And if we simplified that, we would say 2 times 2 is 4x. 2, that's going to be a minus 2 and a minus 1, which would continue simplifying to 4x minus 3. I'll go ahead and box that so it's clear. That's really all there is to this. Like I said, you're just taking the the one function and plugging it into the x of another function and solving it. Take your time, be organized, and these aren't too bad. The only thing that was in here that I wasn't super explicit about is that if you want to, let me see if I can get to the right spot in here. Instead of writing, g of x, for instance, you could write g of x like that, and it means the same thing. So this one where it says HOG, that really says h of g of x. Those two are kind of interchangeable ways to write it. Don't let that freak you out. You can use whichever one you like better.